I'll begin this video with an illustration. Let's take a case in point that I have 3 students in a room. I have student A, student B, student C. And of all these 3 students, I'm going to give each one of them 10 coins. But when these students came in, these are the conditions. The initial conditions they're having are that student A does not have any coin on them. Student B has some 2 coins on them in their pocket. Then student C has got a hole in their pocket. So what do? I go ahead and give student A 10 coins, I give student B 10 coins, I give student C 10 coins, and after giving them each one the 10 coins, they're supposed to get out of this room, or they're supposed to get out of this building. But as they are getting out, the security guard has to first check them to see what they are taking out. Now, when they are checking them, the security guard is supposed to verify if indeed I have given them 10 coins. So when the student guard checks, he checks student A in their pocket have 10 coins. Student B, when they check in his pockets, they discover that he's having 12 coins. When they check in the pockets of student C, because he has a hole in the pocket, he loses some 3 coins along the way to the security guard. So when they count in his pocket, the guy has 7 coins. So now the student, the guard with this kind of results is confused. I've probably told the security guard over the phone that I have handed over 10 coins to each of these guys. But when he's checking in the pockets of these people, he's discovering that A has 10 coins, this one is having 12 coins because it's 10 plus the 2 coins he had initially. Then this one is only having 7 coins because that is the 10 coins minus the 3 coins that he lost because he has a hole in the pocket. So now, it means that in all these answers the security guard is getting, there is something that is not right. Why are they not the same? These answers are not the same. Why? Let's look at student A. This is the perfect guy. This guy came in without coins. I gave him 10 coins and he's having only 10 coins. So this one is verified and true. Now this one, I gave B 10 coins. But how come the security guard is only able to detect or is counting 12 coins in his pocket? Now that is because B had 2 coins initially. In order for the security guard to know, to get the accurate amount of coins that I gave B is supposed to tell the security guard that actually, when I was coming into this room, I had 2 coins. And because I had 2 coins, this guy gave me 10 coins, so that's why there are 12 coins. So it means that the security guard, for him to be able to know, to get the 10 coins, is supposed to get the 12 coins minus the 2 coins that B had initially, so that he's able to verify that indeed I gave B 10 coins. It's the same thing with C. When the security guard counts and he only discovers that C is having only 7 coins, now C has to tell the security guard that actually I have a hole in my pocket. And because I have a hole in my pocket, I lost 3 coins along the way. That's why there are 7. So it means for the security guard to verify that indeed I gave C 10 coins, he's supposed to get these 7 coins that he is counting, and he's supposed to add the 3 coins this guy lost along the way, so that he verifies that indeed I gave C 10 coins. So what am I trying to verify here? What am I trying to arrive at? What am I trying to say? What I'm trying to say is this, that the initial conditions of A are such that in this guy's pocket there was nothing. He's able to discover 12 coins because initially this guy had 2 coins, and here it is 7 coins because this guy had a hole in the pocket. So in order for him to be able to verify that this guy's had 10 coins, there are some calculations he's supposed to make, and these calculations are dependent on the initial conditions of the pockets of these individuals. So the initial conditions of these pockets of the individuals are the ones that are affecting the end result. And that is why the end result of here is exactly 10, because the initial conditions here were no coins. The end results here are 12 because the initial conditions here were such that the guy had some 2 coins before I gave him the 10 coins, and so forth. So these initial conditions are what are causing the discrepancies in these results, or what you may call the error in these results. So it's these initial conditions of the pocket that are causing the discrepancies in these results. Otherwise, if there were no errors at all, it would mean that when the security guards count the coins, they would all be 10 all through. But because there are different initial conditions, So even the coins this guy is counting are different. Now, if I may relate this to the vernier calipers, in my previous videos, there is a very profound statement I made regarding what you must look out for before taking readings on a vernier calipers. Then now, before measuring, you're supposed to ensure that the calipers read 0 when fully closed. Now, these are the calipers. Let's fully close them. When we fully close them and you bring closer, you're supposed to ensure that the first line on the vernier scale is supposed to be coinciding with the 0 mark on the main scale when the thing is fully closed. Right there, it is fully closed. If you have to look at it closely right there, when the jaws are fully closed, the thing is at 0. As you can see right there, the main scale is at 0, and even the first graduation of the vernier scale is coinciding with the 0 mark on the main scale. That is when the jaws are fully closed. The 0 mark here on the main scale must coincide with the first mark or the first graduation on the vernier scale right there. Those two are supposed to be coinciding. They're supposed to be in the same line. That was the condition I set when I was doing my previous videos. When the jaws are fully closed, the initial readings on the vernier must coincide with the 0 mark on the main scale. When this is the case, it means you're dealing with a perfect man. You're dealing with person A because the initial conditions are such that there are no coins in their pockets. However, this may not always be the case. Sometimes during the process of handling the vernier calipers, these vernier calipers are instruments that could get knocks, they could get mechanical shocks, and this might alter this condition, this initial condition of the 0 mark on the main scale coinciding with the first graduation on the vernier scale. Now, if you may look, these jaws, the jaws of this vernier caliper are fully closed. But if you will look closely, if your eyesight is sharp, that is, if you may look closely, the 0 mark on the main scale is not exactly coinciding with the first graduation on the vernier scale. Let's look at this other one. It's the same here. When these jaws are fully closed, you may realize that the 0 mark on the main scale is not coinciding with the first graduation on the vernier scale. From my previous videos, when the jaws were fully closed, you saw that the initial mark on the vernier scale coincided with the 0 mark on the main scale. But when looking closely at these vernier calipers, when the jaws are fully closed, the two marks do not coincide. This means that the vernier calipers are registering a reading when it's not supposed to be doing so. And this simply means that when eventually you take a reading, the reading that you will take will have an error in it. So for us to be able to get accurate readings, we need to remove this error. Just like in my earlier illustration, in order for the security guard to determine the exact accurate amount of coins each student got from me, he had to subtract the money that the students originally had, that is for student B, and he also had to add the money that student C had lost originally. Now, when we close the jaws of the vernier caliper and realize that the vernier caliper is giving a reading, it means that the vernier calipers has gotten an error. This kind of error is what we call the 0 error. By definition, the 0 error is the condition whereby a measuring instrument, such as a vernier caliper, it could be a micrometer screw gauge, it could be any other measuring instrument, registers a reading when there should not be any reading. In this video, I'll demonstrate how to accommodate the 0 error when taking readings on a vernier caliper. Coming up. Ding, 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 ding. When it comes to vernier calipers, there are two types of errors: the positive error and the negative error. The positive 0 error refers to the case when the jaws of the calipers are fully closed and are reading the positive reading. For example, this is our main scale and this is our vernier scale. And now when the scale is fully closed, that is at 0, you find that this graduation is supposed to be coinciding with that one, but instead there is a gap in the positive direction. So when the gap is in the positive direction, we consider that to be a positive 0 error. Likewise, when we are talking about the negative zero error, it is when the reading is negative when the jaws are fully closed. This is how it looks like. This is the initial mark. Here, this part of the diagram, this is representing when the jaws are fully closed. So now when the jaws are fully closed and the zero mark is not coinciding with the first graduation of the vernier caliper, but it is such that the first graduation of the vernier calipers is in the negative direction from the zero mark. It's in the negative direction. So it means that whenever we detect that there is a zero error, we are supposed to first find that error. Then when we find the error, we go ahead and take the correct reading. Now when we take the reading, we know that in that reading, there is an error in it. So after getting the reading, we take away the error so that we get the accurate reading. This is what we are going to do now. Now, before we take the reading, let's look at when the jaws are fully closed. When the jaws are fully closed, this is the zero error. It is such that this graduation is not coinciding with that one. So when they are not, so we need to first find the zero error. So of course we are going to first take the main scale reading. Of course the main scale reading is going to be 0.00 because it is 0.00. Then the vernier scale reading is going to give us, now of course the vernier scale gives us to the second place of decimal, or we multiply it by 0.01, which is the least count. So it's going to become 1, this is 0, 1, 2, 3, 4. Now it is the fourth graduation that is coinciding with a mark up. So it means that it's going to be 0.04. So when you add the 2, it's going to become 0.04. So it means that this 0.04 centimeters, this is our zero error, and it's in the positive direction, so this is positive 0.04. Now let's take the correct reading. So in taking the correct reading, so we shall still main scale. Like I said earlier, it's going to be 9.1. So 9.1 something, so it's going to be 9.10 centimeter. Then from here we are going to count up to where the first, this is 0, 1, 2, 3. It is the third stick or the third graduation that is first coinciding with the upper graduation. So it's going to be 3. So it means that the vernier scale is going to be 0.03 centimeters. Now it is 0.03 centimeters because the vernier scale gives us to the second place of decimal, or it is you count 0, 1, 2, 3 and you multiply it by the least count, and of which in this case the least count is 0.01. When you add the 2, you get 9.13 centimeters. But now this 9.13 centimeters that we have gotten here as the correct reading is having this error in it. So it means for us to get the accurate reading of this vernier caliper, we need to take away this error, because when these two jaws were fully closed, this vernier caliper was giving a reading of 0.04. So we need to remove it so that we're able to get the accurate reading. So for positive zero errors, definitely we're going to say it's going to be 9.13 minus this error so that we get the actual reading. So the correct reading will be 9.13 minus 0.04, and that is going to give us, whenever we are having a positive zero error, we simply subtract that error from the final reading we will have gotten and we get the correct reading. So this is the vernier caliper. Jaws are fully closed. When the jaws are fully closed, it is registering a reading at the point when it's not supposed to. So it means that this vernier caliper is having a zero error. Zero error, it is a main scale. Of course, the main scale reading will always be 0.00. Then the vernier scale reading is going to be, we have this is 0, 1, 2, 3. So it is the third graduation on the vernier scale that is the first one to coincide with the graduation in the main scale. So this is going to become 3 times 0.01, because the vernier scale gives us to the second place of decimal, it becomes 0.03, and definitely 0.03 centimeters. That is our zero error. So now after getting our zero error, we go ahead and get the correct reading now. So to get the reading here, of course, the main scale reading is going to become 8.1.2.3. So that is going to be 8.30 centimeters. Then now we go ahead and read the Vernier scale. The Vernier scale, we start from the first graduation. It's going to be 0, 1, 2, 3, 4, 5, 6. It is the sixth one that is coinciding with a mark in the main scale. So now that we've gotten the sixth one, it's the sixth one times 0.01, it becomes 0.06 centimeters. This is the Vernier scale reading. And when we add the two, it becomes 8.36 centimeters. Now again, this 8.36 centimeters has got an error in it of 0.03. So we need to remove this error from this to get the correct reading. So the correct reading will become 8.36 minus 0.03, and that is going to give us 8.33 centimeters. Now that is how we deal with the zero error when it is positive. This is a positive zero error. It is a positive zero error because the first graduation of the Vernier scale is in front of the zero mark. Now with the negative zero error, the first graduation of the Vernier scale is always behind the zero mark. Now with this one, we are going to count it a bit differently. When we were looking at the positive zero error, we were counting from here. 0, 1, 2, 3. But now when it comes to the negative zero error, we are going to count from backwards to up to the point where the first graduation in the Vernier scale coincides with the graduation in the main scale. So in this case, this is how we are going to do it. To get our zero error first, of course the main scale is always going to be, main scale reading is going to always be 0.00. Then the Vernier scale reading, now this is counting from the back. If you look through here, this is the point where the graduations are coinciding with the main scale. So it means that instead of counting from here to come up to that, we are going to count from this way backwards. So in this case, it's going to be 0, 1, 2, 3, 4, 5, 6. It's the sixth one that is coinciding. So the Vernier scale here, it's going to be 0.06, which is that. So that is a negative error, negative 0.06 centimeters. So now to go ahead and find the correct reading of this, this is going to become 5.1.2. So the main scale reading is 5.1.2, 5.20 centimeters. Then the Vernier scale reading is going to become, this is of course 0, 1, 2, 3, 4, the fifth. So it's going to give us the second place of decimal, that is 5 times 0.01. It's going to be 0.05 centimeters. So this is going to become 5.25. I mean, this is the reading of this Vernier scale, but remember, when this thing had been fully closed, it was having reading negative 0.06. So it means that to get the correct reading of this, it means we are supposed to get 5.25 and add this. So in this case, we're going to get the reading we've gotten here and we subtract the zero error still. So in this case, it's going to become 5.25 centimeters subtract the zero error. The zero error here is negative, so it's minus negative 0.06. So definitely you'll end up finding yourself adding the two. It's going to become 5.25 negative, that is plus 0.06, and your answer will be 5.31. Let's do the second example. So likewise here the zero error is in the negative side, so it means the Vernier scale, of course, it's 0.01. Then we have, this is the main scale. Then the Vernier scale, because it is in the negative direction, the first graduation that is coinciding with the graduations that are coinciding are right there. Because it's a negative zero error, we're going to count from the back. So this is 0, 1, 2, 3, 4, 5, 6, 7. So it's going to become 0.07. This is going to 0.00. So when we add the two, it is 0.07. That is the zero error, but this is a negative zero error because it is in the negative direction. Then we go ahead and make our reading. This is going to be 7.1. So it's going to the main scale reading is 7.10 centimeters. Then the vernier scale reading is going to be 0, 1, 2, 3. It's the third line that is coinciding with the line in the main scale. So it's going to be 0.03. We get that 3 and multiply it by 0.01. That's the vernier scale reading. And when we add the 2, it becomes 7.13 centimeters. Now to get the real exact reading, the one that is accurate, it is going to be the reading we've gotten, the one we've observed, which is 7.13 centimeters, subtract the zero error, and in this case the zero error is a negative, which is negative 0.07 centimeters, and you'll end up with 7.13. Negative and negative will become plus 0.07, and when you add the 2, you'll end up with. In a nutshell, when we are taking our readings and the vernier calipers we were using had a positive zero error, when we get our final reading, all we have to do to that positive zero error is to subtract it off from the reading, and this is what we did here. But if the zero error is a negative 1, we do the reverse. And by doing the reverse, I mean that if we're having a negative zero error, when we get our final reading, we simply just have to add the zero error, and that is what is being done here. But for purposes of making everything uniform, this is what you can adopt. For purposes of being uniform in terms of what formula you should use, to get the correct reading, we say it is going to be equal to the observed reading. The observed reading is the reading that you read before considering the zero error. So it's the observed reading minus the zero error. Now, if the zero error is positive, you'll put the positive number here. If the zero error is a negative, it's going to be minus negative the zero error. And of course, the negative and the negatives will always cancel out and becomes a positive, and you'll find yourself adding like we've been doing here.
This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.